Okay, these are the problems that we talked about in class today. It's just kind of an overview of the first part of chapter 3. What I would encourage you to do is pause the screen on this slide, copy down these problems, and do these problems. I'm going to work these problems out in this video, but you need to do them first. Don't just watch the videos. You need to attempt the problems first, then come back and watch the videos for the solutions. Okay, so pause this screen and do these problems. Okay, this is the second part of the problems. I would encourage you to do the same thing. Pause this screen and do these problems before you watch the rest of the video. It doesn't do you any good to see me work out the problems. You need to try them. You need to get as far as you can on the problems before you watch the solutions. So pause that, and I'm gonna do these problems, and I'm gonna move the screen forward, and we are going to work these problems out. Okay, so the first couple of problems are talking about quadratics. We know this is a quadratic because of the shape of the quadratic. It's asking us to write it in standard form or vertex form. And then we are going to sketch this graph. Now, if you remember, the standard form or the vertex form of a parabola is f of x equals a x minus h plus k. Okay? And I'm not really sure what's going on right there. Okay, I'm not really sure why that wouldn't let me keep going over there. So I'm going to write it a little bit closer over here. So we've got A. A is going to be our positive or negative to tell if the parabola goes up or if it goes down. And it's also going to be our stretching and shrinking factor. So that goes on the outside. X minus h squared plus k. And HK is your vertex, okay? So in this one right here, we have -2, -2 as our vertex. Now you have to be careful with this because your x value is its opposite. Once you put it in, your x minus h, your x minus -2 becomes x plus 2. So you have to be super careful with that. Then our k value, which is our y value of our vertex, is true to value. So nothing is changing about that. This tells us that it is opening down. So that means we're going to have a negative number in front of it for our a value. And we are shrinking by a factor of 1/3. And so that also means that's going to be part of our a value. So we are going to have f of x equals -1/3. That takes into the fact that it opens down and that we are shrinking it by a factor of 1/3. Then we have x plus 2. That's x minus -2 for the x value of our vertex. Then we have our squared. And then we have -2, which is our y value of our vertex, and that's true to value. So that's what moves it up or down. And so when we do our translations, that is true to value. Now we are going to sketch the graph. And so I am going to draw my x and y axis here. Okay. My vertex is -2, 2. And it opens down. So here's my vertex. And remember when we have the factor of 1/3, that actually makes it wider. So we are going to go wider. Okay? So there is our graph. Okay, now the next one, it is already in vertex, the vertex form or the standard form. Different books and different programs call it different things. We are calling this standard form, but you may also hear it as vertex form. So the first thing that we want to identify is our vertex. And our vertex for this one is going to be -3, -2. Okay? And that comes from this point right here and this right here. So x plus 3, that means our h value, or the x value of our vertex, is -3, and then we have -2 on the outside, so we keep that as -2. That's my k value, or the y value of my vertex. The negative here means we're going to have something that is upside down. Okay, it's pointing downward. So here is my sketch. Okay, so -3, -2, so there's the vertex of my parabola. I do not have a stretching or shrinking factor, and so that's what my parabola will look like. Okay, now our next one is not in the vertex form yet. Okay, it's just in -2x squared minus 20x minus 42. So if we were finding zeros and doing some other things with this, we would be able to factor it, and we would be able to identify zeros, because it is in the form ax squared plus bx plus c. And some programs call this standard form, but again, we're talking about vertex form, and we need to get -2x squared minus 20x minus 42 in the form of f of x equals a times x minus h squared plus k. Okay, so what we are doing here is we are going to separate slightly our equation. So I have -2x squared minus 20x minus 42. Okay, now I just kind of spaced it out a little bit. So I want to focus on this right here first. We're going to leave our -42 off to the side for a little bit, and we're going to focus on this -2x squared minus 20x. I can take a -2 out of that, and so that is going to be my a value. The negative means that it's going to be upside down. The 2 is my stretching and shrinking factor, and that 2 is actually going to make it more narrow. So I've got -2, and I'm going to have that outside parentheses. Then I'm going to have x squared minus or plus 10, because I'm taking out a -2. So that -20x becomes plus 10x. Okay, and then I'm going to close this parenthesis right here, and then I'm going to leave my -42 outside of that parentheses. Now what I want to do now is I want to complete the square of this. So I'm looking at my x squared plus 10x, and I am focusing on that to complete my square. So I am going to take half of my 10, which is 5, and then I'm going to square it. And so I am adding 25 to that. Now there's a couple things that we want to look at before we decide what we're going to do with the -42 outside the parentheses. Now the first thing I want you to realize is that I didn't just add 25 to this. I actually added 25 times -2. Okay, that's actually what I added to my function, is 25 times -2. That's -50. Now I'm not doing -50 on the other side of the equation. I have got to keep this equation balanced by adding something to the same side. So I need to add something outside the parentheses that is going to zero out that -50. And so what I actually add is positive 50 to the outside of that. Okay, now let me say that again, just to make sure that you're clear on that. Okay, what I have, where I got my positive 25 from, I took my 10, I took half of that, which is 5, so I did 10 divided by 2 and got 5, and I squared that number. That's where the 25 comes from. Okay? So x squared plus 10x plus 25 can be factored relatively easily. So I created a perfect square trinomial. Now, that 25, if I was multiplying everything out and simplifying it out, would have to be multiplied by negative 2 over here if I was simplifying everything. So I didn't actually just add 25. I added 25 times negative 2 to my function. Now, to keep my function equal, to make sure I'm dealing with equal parts with this function, I've got to zero out that negative 50. So with the parentheses and with completing the square, I have added negative 50 to this part of my function. So I've got to add a positive 50 out here in order to keep everything balanced. So that's why I'm doing the opposite. If I was completing the square and I had the negative 42 on a different side of the equation sign, then I would do exactly the same thing. But that's not what's happening here. What's happening here is I'm keeping it balanced on the same side of the equation. So if I add negative 50 to one part, I have to add positive 50 to another part because I'm dealing with all the same side. Okay, and I know that's a little bit confusing. Practicing those is the best thing that you can do for that. So now I'm going to rewrite what I have. I have f of x equals negative 2. I have x squared plus 10x plus 25. And then on the outside, I have plus 8. So I just simplified that right there. Now what I want to do is I want to factor this. This is a perfect square trinomial, and it allows me to factor. So I have f of x equals negative 2 x plus 5 squared plus 8. Okay? So now I have it in standard form or the vertex form, and I am able to pull out my vertex. Okay, so my h value is right here. My k value is right here. So I have, for my vertex, I have negative 5, positive 8. My vertex, or the shape of my graph, is going to look like this. It's going to be upside down because of the negative. My stretching and shrinking factor is 2. So if I were to graph this, it would look, I would go over 5 and up 8. Okay? And it's pretty narrow because our stretching factor of 2 actually makes it more narrow. And so that is what the graph of this parabola looks like. Okay? Okay. We are no longer talking about quadratics. This polynomial, the highest exponent is 5, so our leading term is telling us that we are going to have a graph who the end behavior is going in opposite directions, something like this. It's also telling us, or the other option is that it could be going like this. So it's going to be going in opposite directions. The end behavior is going in opposite directions. The positive in front of the x to the 5th is telling us it's going to look like this one right here. Okay, so it's going to look like a positive slope. So anytime that we have an odd exponent, our end behavior is that it's going in opposite directions. So that's what we're moving towards. Now, before we can do anything else, we need to identify whatever zeros that we can identify. My y-intercept is going to be 0. So that means my y-intercept is going to be right at the origin because I don't have a constant at the end. And if I don't have a constant at the end, you can consider that plus 0. So the first thing I'm going to do is I'm going to start factoring this. I can take out an x, and then I'm left with x to the 4th minus 1. And x to the 4th minus 1 is a perfect square. So that breaks down to x squared minus 1 and x squared plus 1. So that was a difference of perfect squares. Now I have a difference of perfect squares again. So I have f of x equals x times x plus 1 and x minus 1. Now my x squared plus 1, I can't do anything else with that. I'm going to have to set x squared plus 1 equal to 0 and then determine if I get a complex solution, which is in the realm of imaginary numbers, or if I get an irrational solution, which is also possible. So we'll have to set those equal to 0. So now I'm going to have x equals 0, x plus 1 equals 0, x minus 1 equals 0, and x squared plus 1 equals 0. So my zeros are 0, x equals negative 1, x equals positive 1, and x squared equals negative 1. Okay, so that gives us the first hint that we are dealing with a complex number here. So then we are going to have, so now we're going to take the square root of both sides. So I'm going to have x equals plus or minus the square root of negative 1. And we know that the square root of negative 1 is I. So we have plus or minus I. So be sure that you understand that that is two solutions. That is positive I and that is negative I, because our complex solutions always travel in pairs. If we've got the positive, we have to have the negative, and that always happens. And also remember that I and negative I do not cross the x-axis. Okay, so here I've got negative 1, and here I've got positive 1, and then here I've got 0. So I am going to, so my graph is going to cross the x-axis here, here, and here. So it crosses the x-axis 3 times, and that accounts for all of our real solutions. These are complex solutions. They do not cross the graph. I and negative I, they don't cross the graph, so we don't know the graph's behavior at this point. Now we are moving, we've got a positive leading coefficient, so it is moving in this direction. Okay? And so that is the sketch of our graph for number 4. Okay, so our next problem, number 5, is asking us to use synthetic division well, actually, it's just asking us to do synthetic division. I'm actually going to take it a little further than that and go ahead and find the other zeros, but we really are only being asked to do synthetic division here. Now, the first thing I want you to think about, because of the rational root theorem that we talked about in class, I want you to decide if you think that this might work out. Is this a situation where it's possible that this is a factor of this polynomial? And so you can just think about that for just a second, and then I will tell you the answer. So, if you remember, the rational root theorem talks about taking the factors of our constant, which is negative 24, over the factors of our leading coefficient, which is 2, to determine the different numbers that could potentially be, or that are, potential zeros of this polynomial. And so what we're asking ourselves in this situation is 8 a potential solution or a potential zero to this polynomial based on the rational root theorem? And the answer to that is yes, because positive 8 is a factor of negative 24. So it's possible in this situation that we will get a 0 for our remainder. If this was a 9 or maybe a 7, then it would not be, because those are not factors of 24. And so that is how we go about that. Now, the rational root theorem does talk about using the factors of this over the factors of this. So that's what it talks about. But where I tell students to start, I tell students always to start here with your constant. So kind of go through several numbers that are factors of this constant, and you are likely going to find one of the solutions. The rational root theorem lists all of the rational possibilities, but to get started, I always start with the negative 24. Okay, so let's do this. Let's divide 2x to the third minus 17x squared plus 11x minus 24. So I am going to write down all my coefficients. So I have 2, negative 17, 11, and negative 24. Okay. I pull down my 2. I say 8 times 2 is 16. Negative 17 plus 16 is negative 1. 8 times negative 1 is negative 8. And I'm left with 3. And 8 times 3 is 24. So I am left with 0, a remainder of 0. So that means that x minus 8 is a factor, and it means that 8 is a solution. So when I look at this as x minus 8, and I have 2x squared minus x plus 3, okay, to factor it more, I look at trying to factor this trinomial, 2x squared minus x plus 3. My sum is positive 6, and my sum is negative 1. My product is positive 6. And I find that there are no numbers that multiply together give me positive 6 and added together give me negative 1. Now, some of you may be thinking, well, Alicia, what about 2 and 3? So 2 times 3, or negative 2 times negative 3. Okay? 2 times 3 is 6, but 2 plus 3 is positive 5. Negative 2 times negative 3 is positive 6, but negative 2 plus negative 3 is negative 5. Now, in order for me to get negative 1 as my sum, I'd have to have 2 times negative 3. But that gives me negative 6, and I've got to have positive 6. So none of those work, but I wanted to kind of talk through why they don't work. So we are going to have to use the quadratic formula or completing the square. You can use the quadratic formula or completing the square on any trinomial that can't be factored. I tend to use the quadratic formula anytime that I have an a value other than 1. So because I've got a 2x squared here, I'm going to go ahead and use the quadratic formula. You can use completing the square. If that's what you prefer, don't hesitate to use completing the square. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. So my a value here is 2, my b value is negative 1, and my c value is 3. Okay, so I have negative 1. Okay, so be careful with that. It's negative b, so negative 1 plus or minus the square root of b squared, and I am squaring negative 1. So negative 1 squared is going to be positive 1. So be sure you've got those parentheses there. So it's b squared minus 4 times a, which is 2, times c, which is 3. Okay, and I am not really sure why that is cutting off right there. I apologize about that. Okay, and so then I have 2 times a. Okay, so negative 1 is going to be positive 1, plus or minus. Negative 1 squared is 1, minus 4ac. So that's negative 4 times 2 times 3, and that's going to give me 24. So minus 24 all over 4. 1 minus 24 is 1 plus or minus the square root of negative 23 over 4. And if you remember, and I'm going to go this way just because the screen is acting a little funny, anytime that you've got a square root, you've got to pull your I out. So I'm going to have 1 plus or minus I on the square root of 23 over 4. So let's talk about this. This is 2 of my factors. It's 1 plus I on the square root of 23 over 4 and 1 minus I on the square root of 23 over 4. This is a complex solution, so it has to travel in pairs. We have to have the plus part and the minus part. Okay? Now, if you remember, we found that this was a solution. So 8 is a rational solution. Rational solutions stand alone. So for this one, we have 1 rational solution and 2 complex solutions. And that accounts for all 3 of our solutions because this is to the 3rd power. We don't have any multiplicities other than 1. And so that is the solutions to these. Now, this particular question was only asking us to do synthetic division, but I wanted to go ahead and do all of that so that you could just see it worked out. Okay, now number 6 is asking us to simplify, and we are going to simplify with this one. This has a complex number in the denominator of a fraction or the denominator of a rational. For something to be truly simplified, we have to get rid of that 8 plus 2i. So the way that we get rid of that 8 plus 2i is we multiply by its conjugate. So I have 8 minus 2i right here. Now, if I'm going to multiply the bottom by 8 minus 2i, I also have to multiply the top times 8 minus 2i. Okay, so I'm actually going to FOIL the numerator, and then I'm also going to FOIL the denominator. So let's do that. So I have negative 1 times positive 8, and that's negative 8. Then I have negative 1 times negative 2i, so I have positive 2i. I have 4i times positive 8, so that's positive 32i. Then I have 4i times negative 2i. That is negative 8i squared. And so we've got several things that we need to simplify on the numerator. So hopefully you caught a couple of those things. We're going to go ahead and FOIL the denominator, and then we'll come back and simplify. So in the denominator, I have 8 times 8, which is 64. And then I have 8 times negative 2i, which is negative 16i. Then I have 2i times 8, which is plus 16i. Then I have 2i times negative 2i, which is going to be minus 4i squared. Okay, so now let's simplify. In the numerator, I have negative 8. Then I have 2i plus 32i. Okay, that is going to give me 34i. Then I have negative 8 times I squared. And if you remember, I squared simplifies to negative 1. That's one of the things that you want to remember. The square root of negative 1 is I, but I squared is negative 1. So you definitely want to have that memorized. Now, in the denominator, we've got 64. Okay, then I have negative 16i and positive 16i. That is exactly what we wanted to happen. When we multiply by its conjugate, we're going to get a difference of perfect squares, and that's exactly what we want. Then I have minus 4i squared, and that I squared is negative 1. Okay, so negative 8 plus 34i. Negative 8 times negative 1 is positive 8. 64 minus 4 times negative 1, that is also going to give me 64 plus 4, because negative 4 and negative 1 is a positive number. So I end up with 34i over 68, and that does need to be simplified. 34 goes into 34 and 68, so that leaves me with 1/2 I. And that is my final answer. Now, the next 4 problems, we are solving to find the zeros. That's what we're doing. We're solving to find the zeros. And we have some rational zeros, we have some irrational zeros, and we have some complex zeros. So those are all the different kinds of zeros you have. Now remember, rational zeros stand alone. They do not need its conjugate or its partner. Rational numbers can be completely independent. It's complex numbers and irrational numbers that have to have its opposite with it. So keep that in mind as you're solving these. So the directions are find all the zeros. So this particular problem right here, we can factor this by grouping. So I am going to just start by looking at these 2 parts of the equation. And I can take an x squared out of both of my first 2 terms, and I'm left with x minus 1. Then I can take a negative 4 out of the second 2 terms, and I'm left with x minus 1. So I have x squared minus 4, and then I have x minus 1. X squared simplifies to x plus 2 and x minus 2. And then I still have my x minus 1. So I have factored this. So in factored form, this is f of x equals x plus 2 times x minus 2 times x minus 1. I'm going to set each one of these equal to 0. So I have x plus 2 equals 0, x minus 2 equals 0, and x minus 1 equals 0. So I have negative 2, positive 2, and positive 1. Okay, so these right here, that's what we call linear factors. So this is the factored form of this function. Here, the negative 2, positive 2, and the 1, those are my zeros of my function. You might also hear those called solutions. And remember that our solutions are also our x-intercepts. Okay, now I'm not being asked to graph this. All I'm being asked to do is find the zeros. Okay, let's do the next one. So the next one is f of x equals x to the 4th plus 2x squared plus 1. Now we are going to factor this the same way we would factor x squared plus 2x plus 1. So if we factored x squared plus 2x plus 1, that is a perfect square trinomial, and we can factor that by saying x plus 1 times x plus 1. Okay, that's how that gets factored. And that's because 1 times 1 is 1, and 1 plus 1 is 2. So instead of having the x there, we are going to have x squared. So I'm going to have x squared, and then I'm going to have plus 1 and plus 1. Now, you might be tempted to say, oh, well, that's difference of perfect squares. X squared is perfect, and 1 is perfect. But look closely. We are not subtracting x squared and 1. We are adding x squared and 1. So be very, very careful of that. Okay? So we need to go ahead and set x squared plus 1 equal to 0 and x squared plus 1 equal to 0. So then I get x squared equals negative 1. Okay? I take the square root of both sides, and when I do that, don't forget, you've got to account for your plus and your minus. So I have x equals plus or minus the square root of negative 1. Okay, now the square root of negative 1 is I. So I have plus or minus I and plus or minus I. So every one of my solutions is complex. Okay? So my answers are positive I and negative I. Each one of them has a multiplicity of 2. Positive I shows up twice and negative I shows up twice. So if I were to write this out, it would be I and negative I, and then I and negative I. So I has a multiplicity of 2, and negative I has a multiplicity of 2. Now, typically when we have a multiplicity of 2, we know that it hits the x-axis and changes direction. It goes back the other direction. But here we're talking about imaginary or complex numbers, and so we don't even cross the x-axis. But it is important for you to kind of be thinking about the multiplicities. Okay, so that is number 8. We're not graphing this, but if we were graphing it, this particular graph would not cross the x-axis. It would not cross the x-axis. Okay, here is number 9. Now this is a quadratic. So the first thing that I do when I look at a quadratic is I look at whether or not I can factor it. So I am looking for 2 numbers multiplied together that give me 8. Added together give me -2. And I know that many students want -4 and +2 to work, because -4 times +2 gives me -8, and -4 plus +2 gives me -2. So you have to be careful here, because I'm looking for a +8. I'm looking for a +8, not a -8 for my product. And so those numbers do not work. So this can't be factored. So we are going to have to look at completing the square or the quadratic formula. And this is a very nice, beautiful one to show completing the square. So that's what we're going to do for this one, is we're going to do completing the square. So I'm going to have 0 equals x squared minus 2x plus 8. And then I am just going to rewrite that as x squared minus 2x plus 8. So all I did was I switched what was on what side. That's all I did. So now I'm going to subtract 8 from both sides. So I have x squared minus 2x equals -8. Okay? So when you're completing the square, you have to have everything with a variable on one side, and you have to have the constant on the other side. So be sure that you have that worked out. The next thing that we're going to do is we are going to take half of our b term. So our b term is -2. Half of that is -1, and I am going to square that. -1 squared is +1. And because I've added it to the left-hand side, I also have to add it to the right-hand side. Now, this situation, we are adding it to different sides of the equation, and in that situation, we have to make sure that we add the same thing to both sides. When we were doing it to find the vertex of the parabola, we weren't dealing with 2 different sides. We were dealing with the same side of the equation, of the equal sign, and that's why we had to add the opposite to keep it balanced. Okay, now we are going to factor. So x squared minus 2x plus 1 factors to x minus 1 squared. And then when I simplify over here, I'm left with -7. So I have x minus 1 squared equals -7. Now I take the square root of both sides, so I'm left with just x minus 1 equals plus or minus, don't forget that plus or minus, -7. Okay, now I've got a negative inside a square root, so that means I need to bring out my I. So on my right-hand side here, I'm going to have I plus or minus I on the square root of 7. And that is not a real number. That is a complex number. So we are no longer dealing with this graph crossing the x-axis because we have a complex solution. Now my last step is I've got x equals 1 plus or minus I on the square root of 7. So I do have 2 solutions for this. My solutions are 1 plus I on the square root of 7 and 1 minus I on the square root of 7. Okay? Those are my solutions. Okay, one more, and then you will be ready for your quiz. One more. Okay, I have x to the third plus 6x squared plus 9x plus 2. This particular problem, using the rational root theorem, we don't have that many different things to check. My leading coefficient on my leading term is positive 1, and my constant, or my term without a variable, is positive 2. So I've got negative 1, positive 1, negative 2, and positive 2. So we can try different things. So any 4 of those would be reasonable to try. So let's try negative 1, and we're going to see if negative 1 works. Okay, so I'm going to put negative 1 in my box. Then I've got 1, 6, 9, and 2. Okay, so I bring 1 down. Negative 1 times 1 is negative 1. 6 in negative 1 is positive 5. Negative 1 times 5 is negative 5. So I'm left with 4. Negative 1 times 4 is negative 4, and I can tell that that doesn't work. So I cannot use negative 1. We could do positive 1, we could do negative 2, or we could do positive 2. I'm going to go ahead and do negative 2. Okay, so I bring down my 1. Negative 2 times 1 is negative 2. 6 in negative 2 is 4. Negative 2 times 4 is negative 8. 9 and negative 8 is positive 1. Negative 2 times 1 is negative 2. So that works. Okay, so what that means is negative 2 is a solution. Negative 2 is a rational solution, and it is one of the places that this graph crosses the x-axis. Okay, so now I've got to find out what else works. So if I were to write this in factored form, I would have x plus 2, and then I would have x squared plus 4x plus 1. Okay, so what I'm going to try to do is I'm going to try to factor this quadratic. And as I start factoring this quadratic, I realize there's no two numbers multiplied together that give me 1 and added together give me 4. So for this one, I'm going to do the quadratic formula because there's some simplifying that we have to do with the quadratic formula that sometimes we don't like to remember to do. So I am going to remind us how to do that. So I've got negative b plus or minus the square root of b squared minus 4ac. And all of that is over 2a. Okay, so my values that I have here are a is 1, b is 4, and c is positive 1. Okay, so negative b, that's going to be negative 4, and that's plus or minus the square root. Then I have b squared, so that's 4 squared, minus 4 times a, which is 1, times c, which is also 1. And all of that is over 2 times a. So I have negative 4 plus or minus 16 minus 4. 16 minus 4 is 12. So I have many students that when they get to this point right here, they are done. They do not want to do anything else. But I'm here to tell you, this simplifies further. So I want you to focus on that 12 right there. So I'm going to kind of move right over here so that we can kind of focus on what's happening right here. That 12 can be broken down into 4 times 3. Now the reason that I chose 4 is because 4 is a perfect square. 4 is a perfect square. If I had chosen 6 times 2, that doesn't get me anywhere because I'm taking the square root of numbers, and 2 and 6 are not a perfect square. But 4 is, so that's why I break 12 down to 4 times 3. So I'm going to take the square root of that 4. So I'm going to have negative 4 plus or minus 2 on the square root of 3 over 2. At this point, I've got a 4 here, a 2 here, and a 2 here. Because all 3 of those are divisible by 2, I can simplify. And that's going to simplify to negative 2 plus or minus the square root of 3. Okay, so all these kind of canceled out. And so negative 2 plus or minus the square root of 3, this is a real number. Negative 2 plus or minus the square root of 3 is real, but it's irrational. So this does cross the x-axis, but it also travels in pairs. I've got to have negative 2 plus the square root of 3, and I have to have negative 2 minus the square root of 3 as part of my answers. Okay, so I want you to understand what's happening there. It is irrational, so they have to travel with conjugates. They have to be pairs, but it is crossing the x-axis. Those are real solutions. They're just irrational ones. Okay, hopefully this was helpful, and this is something that will help you prepare for your quiz. So I will talk to you soon.